Before the TI-99/4 launched, the US computer press was talking like Texas Instruments had already won the personal computer battle. TI sold more chips than anyone else in the world. They'd conquered the calculator market, they already produced mini computers, and now they were turning their considerable resources towards a nascent market that was occupied by two-year-old computers from smaller companies and, in the case of Apple, a scrappy startup. Texas Instruments had the luxury of learning from the mistakes each of these companies had made to produce something that would take the market by storm. Yet 4 years after it launched, the $1,150 TI-99 was being sold in bargain bins for $50, and Texas Instruments were taking a $330 million write-off. Was the TI-99 really that bad? And why was it such a flop? This is the Texas Instruments TI-99 story. Before we get started, the computer behind me and another beige TI-99 that you'll see in the video were kindly loaned to me by Adrian Black from Adrian's Digital Basement. His YouTube channel focuses on repairing retro computer equipment, and he's worked on a TI-99. He might be working on the one behind me. I found out it didn't actually work. I'll leave a link in the description and at the end of the video if you're interested in looking at one of my favorite YouTube channels. Texas Instruments was and is an innovative creator of electronic components. In 1954, they created the world's first silicon transistor. Chips are just a package of millions of silicon transistors built into an integrated circuit, another TI employee invention. So their work was instrumental in creating today's modern equipment. They designed and manufactured the first transistor radio, the Regency TR-1. They didn't make a go of the transistor radio, but they invented the handheld calculator and went on to dominate calculators in the 1970s. At that time, they were the must-have business desk accessory. Faster, more compact and simpler than adding machines, this made calculations so much easier and improved productivity and profitability. TI didn't only build calculators, they designed and manufactured all the chips that went inside them, so they were able to fend off competition such as Commodore that built calculators that used TI chips. In fact, TI started selling their calculators for less than the price of the chips they sold to Commodore, killing Commodore's main revenue stream. That led to Commodore changing tack and creating a personal computer, the Commodore PET. While pocket calculators were printing money, as soon as the Tandy TRS-80, Apple II and Commodore PET launched in 1977 and promptly started selling like the proverbial hotcakes, Texas Instruments realized that they'd put all their money into securing what could be a dying market. A computer couldn't just do one calculation every second, it could do thousands. Thankfully, Texas Instruments already had experience with computers. In the 1960s, they created a mini computer that they sold to the oil industry, a flourishing business in their home state of Texas. Sensing the mini computer market was moving from 8 to 16-bit chips, TI invested in a new CPU that launched in 1976, the TMS-9900. They used it for their own machines and tried selling it to other computer firms. Although it was a forward-looking 16-bit design, it was hobbled with an 8-bit peripheral bus and there wasn't much interest. 1977 saw a rush for not only personal computers, but video game systems as well. Atari released the VCS, which allowed for much better games than the simple bat and ball clones most customers had seen up until this point. TI, as I've said, was the largest manufacturer of semiconductors and had a commanding presence in the calculator market, so they had a substantial war chest to go after new markets. They started designing a $200 video games console that used cartridges and a personal computer to compete with the TRS-80, spinning up two teams to develop these two separate devices. There was also talk of a third machine, a business computer with a 10 megabyte hard drive. The business computer would never happen. TI saw it as a threat to their mini-computer business. The video games console and the personal computer projects slowly began to address similar markets, and a turf war broke out between the two teams. TI ended up merging both projects. they would launch one machine that would be both a video games powerhouse and a killer personal computer. And it would use TI chips, of course, including the 16-bit TMS-9900, despite there not being a great desire within the team to use it. But then TI's mantra was one company, one computer architecture. Why use other chips? Use TI chips and keep all the profit. The team had studied those three initial computers. The TRS-80 had no sound or colour, so TI's machine would include both. 4 kilobytes of memory was insufficient for many applications, so their machine would come with 16 kilobytes as standard. Games were important, clearly, if it was going to be a video games console, so the computer would support sprites, a way to make objects move faster around the screen. As journalists became aware of TI's machine, they saw that there was a good chance the large company was going to swallow up the minnows of Radio Shack, Commodore and Apple. After all, TI had done this for calculators, to Commodore no less. They've defeated them once, surely they could do it again. TI had the money to take the market. They had the marketing budget and the connections to get it into the same stores that carried their other computer products, a problem all three minnows were struggling with. TI lent into this perception when they launched their computer, the TI-99/4 in 1979. Texas Instruments had the know-how to produce the best personal computer given their years of experience building business computers. They were a large company that had reliability built in through stringent testing. Mass manufacturing meant an affordable price. This was both a personal computer and a video games console, all for only $1,150. For that money, inflation adjusted, today you could buy a Dell XPS 13 and a PlayStation 5, a Microsoft Surface laptop and an Xbox, a Nintendo Switch 2 and a MacBook Air, and a Steam Deck and an iPad and a Google Pixel phone, and still have money left over. So you can imagine buying a TI-99/4 in 1979 wasn't a snap purchase. It was pretty expensive. That's not to say it wasn't good value compared to the competition. The TRS-80 and PET might be half the price and the new Apple II Plus about the same price, but the Apple didn't come with a colour monitor, or indeed any monitor. Only the Apple had high-resolution colour graphics and the same amount of memory, 16 kilobytes, and none of them could touch the TI-99's 3-voice polyphonic sound with white noise channel. And all of this in a compact machine from a trusted name. The case was solid enough. Although mainly plastic, there was brushed metal covering the top that made for something that looked better quality. It reminded one reviewer of something from Bang & Olufsen. Today we look at the chiclet keyboard and wonder just what TI was thinking. The TRS-80 and Apple II Plus both had proper keyboards. Even Commodore had abandoned their chiclet keys as a bad job with the 2001 N. But there was method to TI's madness. They'd spent the 70s selling a lot of calculators to people who had no problem feverishly entering calculations all day long on chiclet keys, and there wasn't any pushback to change to full travel electric typewriter style keys. TI engineers had chosen it precisely because they spent so much time tapping on TI calculator keys. It may be no coincidence that both Commodore and TI, both calculator companies, went for a keyboard reminiscent of a calculator. Personal computers were in their infancy and companies were still searching for a computer design that hit the sweet spot of customer satisfaction and affordability. What's more, the spacing of the keys allowed custom overlays to be used for commercial software. But while it might be understandable a calculator maker would make a computer with calculator-style keys, if TI had been watching the computer market closely, they'd have seen the pushback Commodore received over their chiclet keyboard. Maybe if they'd done their extensive customer testing, they'd have found out that there was very little travel on the keys, no key repeat, and little feedback that a key had even been pressed. As far as everyday practicality went, the keyboard was awful. And then for some reason there were 2 space keys. Programs could be loaded from cassette tape or instantly with cartridges or solid-state software command modules that slotted in to the right of the keyboard. Programs benefited from 256 by 192 16-color graphics. There There was an expansion port, and TI already offered the first module, a speech synthesizer using the tech from its popular Speak and Spell educational toy that had launched a year earlier. With Speak and Spell a success, it's understandable TI would place such importance on this device. They'd created one of the first mass-market chips that could output speech, and this had the possibility to revolutionize society with machines able to speak almost anything. Like the invention of the laser, it seemed revolutionary once someone could find a use for it, find the killer app. Parents looked to home computers as an educational aid that could prepare their kids for a world where computers became ubiquitous, so TI launched a range of educational software. There was also productivity titles including physical fitness to get you in shape, and the seemingly obligatory household budget management title that all computer makers seem to offer that could work out that you were in debt from the expensive computer you'd just purchased. Well, you couldn't exactly justify this kind of expense just to play games, could you? But if you could tear yourself away from the riveting Home Financial Decisions program, there were various cartridge games produced with the help of Milton Bradley and controlled not with joysticks, but with what TI called remote controllers. Games like Hangman and Connect 4 might look underwhelming today, but then computer video games in 1979, even for the Atari VCS, weren't spectacular. The best it could offer were arcade hits like Breakout. The best you could get on the TI-99 was Zero Zap. Playing with remote controllers wasn't a lot of fun either. They weren't the best controllers ever produced, but then the overall quality of joysticks in the early days of video games wasn't great. It took a few years to come up with something truly usable like the NES or PlayStation controllers. TI's decision to prime the engine with a range of launch titles definitely helped compete against existing machines that had 2 years worth of third-party titles. But clearly better software and more software was needed. Maybe the new army of TI owners could create a blossoming market of third-party titles. TI offered a series of programming aids cartridges, but when it came to publishing titles, this was a closed shop. If you wanted to publish software, you had to do it through Texas Instruments. Like Nintendo, Microsoft and Sony today, they held the keys to the video console kingdom and wanted a cut of every game sold. This console locking was a new thing. Atari had blocked unauthorized third-party VCS cartridges in 1978. Another thing that stifled growth was the TI-99's very strange hardware design. The 16-bit CPU was designed for mini-computers that time-shared between multiple users. It produced an odd memory layout with just 256 bytes of RAM. The main 16 kilobytes of memory was actually video memory. This was accessed over an 8-bit bus, meaning any access took 2 cycles. A computer spends a lot of time reading and writing to the memory, so this effectively halved the performance of the 3 MHz CPU. Competing 8-bit chips rightly used a 16-bit bus to address memory. Users could write their own programs in TI's own version of BASIC, which avoided some of the pitfalls made by the 1977 machines. It had floating point numbers, 2-dimensional arrays, comprehensive string manipulation functions, and the ability to define functions. Drawing high-resolution lines wasn't possible like on the Apple II, but it was possible to redefine characters to make your own 2-color bitmaps. This could be used to create lowercase letters, something TI should have realized was important on a home computer from reading what customers were demanding from competing systems. The if statement only allowed the program to jump to another line of code. It wasn't possible to set a variable or print something on the screen. This produced bizarro code which was even more spaghettified than regular BASIC, making it difficult to write anything serious. There were other omissions like the ability to print text at a certain point on the screen. Editing programs were slow and awkward compared to the older competition. Again, a lesson TI should have learnt. But the main problem with TI BASIC was it was so slow. This was partly due to how the machine was architected, but mainly that the BASIC interpreter wasn't written in machine code, but in an intermediate language, GPL. It's like trying to order food in Paris in English but using a German to translate from English to German and then to French. Not exactly fast, which again meant it was hard to write anything serious. Whilst researching this video, I made my own subroutine to print text at a certain location on the screen. It was so slow you could literally see the letters appearing on the screen. There wasn't even an option to access memory directly through poke and peek to write some fast routines to speed up parts of your basic program. TI would improve things with the TI Extended Basic cartridge in 1981 that included support for sprites, a bump in speed and a few other changes, but it was still worse than other home computers. The public was underwhelmed by TI's new machine. There wasn't much software, there was no support for disk drives, and typing on the keyboard was awful. This wasn't a serious machine. Atari had released the 400 and 800. The 800 had a better keyboard and both machines were less expensive. TI started discounting their new computer. They rolled out more accessories to improve the value proposition. There was a printer, a modem that allowed access to TextNet, TI's competitor to CompuServe, where you could access content from Reader's Digest, a serial interface, and finally a floppy disk drive. The monitor bundle at launch had actually been a hack on TI's part. They had had problems meeting the Federal Communication Commission's stringent rules around shielding computers from interference. TI tried many solutions but eventually gave in and bundled the machine with what was essentially a Zenith TV to get around the issues. Soon these problems were solved, and by 1980 it was possible to purchase a $50 video modulator instead of the $450 Zenith TV and plug your TI-99 into an existing TV, making the computer a more reasonable proposition. Texas Instruments experimented with $200 rebates. They'd sold less than 20,000 machines by the summer of 1981, a very small number compared to Tandy and Apple. It was irrelevant as a video games console with the lack of interesting titles, especially when Space Invaders launched on the Atari VCS in 1980. Some inside TI thought it was better to cut their losses and create a new computer design that cost half the price, this time using the 8-bit Zilog Z80. The new design was presented to TI's management, where it fell with a big, dull thud. A TI computer should use a TI chip. What was this Z80 nonsense? A competing team came up with a new low-cost computer design using the TMS-9900, of course, but this also bit the dust. No, the team convinced themselves that the problem with the original machine was that keyboard and it needed to be cost reduced. So in 1981, the world was introduced to the TI-99 4A. At $525, it was half the price of the original machine, and it could now use any common or garden TV. TI put more emphasis on marketing. There was a new flash advertising campaign fronted by popular comic Bill Cosby, who was paid a cool $1 million. It was sold not just in computer shops, but department stores. The computer would come to the masses, and by hook or by crook, it would be a hit. The graphics chip had been upgraded with a new bitmap mode and to allow for 50Hz PAL and CCAM video output, critical to sell the computer worldwide. Soon it was appearing in shops across the globe. When Texas Instruments' range of accessories were daisy-chained together off the side of the computer, it all became a bit silly. It was in TI's interest for you to buy the lot, so they offered the peripheral expansion system in 1982, a big box that accepted up to 7 expansion cards. You could now add 32 kilobytes of memory, a floppy disk, modem and serial support, plus P-code, a Pascal development environment. TI continued to position speech as a differentiator, and their implementation for the time was very good. I mean, you could make your computer sing.
Little darling, it's been a long, cold, lonely winter.
It was built into games like TI Trek.
Plan on hiring at Enterprise.
Texas Instruments tried to pitch it to parents of very young kids. The educational titles could speak to them before they could even read. But in truth, there wasn't really enough reason to pay the money for the additional speech module. With Texas Instruments being the gatekeeper to the software kingdom, the range of titles remained small, with only one title for a particular subject area. There wasn't the competition of other systems where the best program won, which raised the bar for all programs. As the science fiction author Jerry Pournelle said, TI had rightly concluded that the hobbyists and hackers were a tiny part of the market, and wrongly concluded that they were therefore unimportant. TI actively discouraged the development of software. They held back information of how the machine worked. Development tools didn't allow budding programmers to take advantage of the convoluted TI-99 hardware, and it took TI mini-computers to create the initial catalogue of software. It used the TMS-9900, a non-standard CPU, at a time when other home computers were coalescing around the 6502 and the Z80, so developers needed to learn a whole new set of skills. If you did manage to produce something, you had to distribute it through Texas Instruments, if they decided your software was something they wanted, and then they would take 90% of all the profits. TI still pitched their machine as a home computer, in fact the home computer, but it could also tackle some business duties now it had a more usable keyboard. They released the TI Writer word processor, which, when used with the disk drive and printer, offered some practicality. The Microsoft Multiplan spreadsheet application arrived in 1983. You could still buy household budget management if you really wanted as well. But the business market in 1981 continued to be dominated by the reliable Apple II. There were more educational titles, and TI pushed their version of Logo, a simple programming language for kids. After all, computers were the future and everyone would need to code, so best to get kids started young, or invest in their future with the Plato Basic Skills and High School Skills courseware to teach them maths, reading, social studies, grammar and science. I mean, they'll thank you for it. It was just 108 packages for $49.95 each. That's only $5,394.60. I mean, where else are they going to learn this stuff? School? If you did sit your kids down in front of the computer for endless computerized homework, they'd likely be swapping it out for a game or two. Games had improved since the simple programs of 1979. At the end of 1981, there was a good Space Invaders clone, TI Invaders, and in 1982, maybe the definitive game for the TI-99, Parsec. It showed off what could be done in machine code with the new bitmap mode. TI also started rolling out more programming tools like the Mini Memory Machine Code Assembler. These games were good, but computers had moved on in the 2 years since the original TI-99-4 had launched. Tandy had the Color Computer, Commodore had just launched the VIC-20. TI engineers took Commodore's latest machine apart and scoffed at how inferior it was. It only had 3.5 kilobytes with impractically large text. This wasn't a real computer. But it could be easily expanded, and computer users would find it was a lot more usable than Texas Instruments' hobbled system. And Commodore went big with the launch of the VIC-20. TI had Bill Cosby, while Commodore had William frickin' Shatner, a Starship captain no less. And for Commodore, beating TI was personal. Remember, Commodore's main business was making calculators until TI had shut them out of the market by selling finished calculators for less than the price it cost Commodore to buy TI's chips. Commodore had pivoted to personal computers, and here was TI muscling in on their new patch. This time, Commodore was prepared. They owned the fabs that made their chips, they felt they had a superior product, and it cost less to manufacture. The two companies soon found themselves in a video game showdown bigger than Space Invaders. The retail price of the TI-99 was $525 and the VIC-20 was $299. By the end of 1981, the TI-99 had dropped to $450. Then in early 1982, it was $400. By September, it had dropped to $325 with a $100 mail-in rebate, so effectively $225. This was $200 by the end of 1982, with Commodore matching Texas Instruments dollar for dollar. At this point, the strategy was working. TI had cost-reduced the computer and were making a profit on the machine that was selling 150,000 every month. It was outselling the VIC-20 3-1, and it was America's most popular home computer. There was so much demand that by Christmas 1982 it was sold out. Texas Instruments had sold 500,000 machines that year. In 1983, they were confidently predicting they'd sell 3 million. But Commodore had a grudge to settle. In January, they dropped the price of the VIC-20 to $125. TI had to match. By April, both machines were down to just $100. TI couldn't even manufacture their computer for that price. Then, disaster. The TI-99 had to be withdrawn from the market because of a potential electrical shock hazard. Stock continued to back up. The problem cost TI $50 million. After a month, sales restarted, but the momentum was lost. By July 1983, the VIC-20 could be had for less than $80, or you could buy a new Commodore 64, a machine vastly superior to the TI-99 for only $200. Atari was still hoping to get $289 for the 800. This was madness, but not utter madness. Once you bought your TI-99, there were all those expensive cartridges to buy, like that Plato educational course, all with a good markup. Just like the Xbox, the Switch and the PlayStation, you sold the machine for a loss and then made it up on the software, the old razor blade sales model. And part one of the scheme had actually worked. Sales of both machines boomed as the public embraced cost-effective computing. But until customers started buying all this expensive software, TI was losing money hand over fist selling all those machines at a loss. They released a cost-reduced model in Apple II Beige, no more brushed metal. The hardware was cost-reduced by merging multiple chips into one custom design. The keyboard improved as well with improved Alps-style keys. TI's balance sheet was red, and worse, customers weren't buying all that expensive software and peripherals. In August, they reduced the price of peripherals by 50% and offered $100 of free software. But if you're selling a computer to a family for only $99, they weren't the sort of people with all the disposable income for a disk drive, a modem, for the pay-by-the-minute TextNet bulletin board service, or a range of expensive cartridges. Allegedly, the most popular accessory for the TI-99 was a cable that converted the non-standard joystick port to use cheaper third-party joysticks. Undeterred, Texas Instruments launched a new computer, the Compact Computer 40, and the professional computer designed for the business market. They weren't done with the TI-99 either. There was a reason why they referred to the TI-99 computer as a TI home computer. They intended to expand the TI-99 4A into a range of machines. In the heady days of 1982, when TI thought that they could own the computer market, they took aim at the Timex Sinclair 1000 that sold for only $100. Surely they could make something to compete with that as well. So the TI-99-2 project was born. It saw the return of the chiclet keyboard to save money. There was no color and only 4 kilobytes of memory. But critically, it still used cartridges that would provide all the profits. Texas Instruments revealed it at the start of 1983 with the same price as the Timex Sinclair 1000, $99. But just a few months later, the price war meant the TI-99 4A was selling at that same price, and there was no market for this budget model. 1982 also saw the company start work on a deluxe model. The TI-99-8 would have a larger keyboard, 64 kilobytes of memory, expandable to an amazing 15 megabytes, more ports on the rear, and extended basic and speech included as standard. TI brought it to the 1983 Summer Electronics Show, but it wasn't ready for prime time, and they found it couldn't compete with what was already out there, so it stayed behind a locked door. Rather than a lifeline for TI's computer division, it became an embarrassment. Journalists took photos of the door, wondering why they weren't allowed to see this mystery machine. With Texas Instruments losing hundreds of millions of dollars on a computer that they were essentially giving away, finances caught up with the program. In October 1983, all TI-99 work stopped, and the remaining TI-99 4A stock was sold off. Their computer, that once sold for $1,150, was now in the bargain bin for as little as $49. Texas Instruments took a $330 million write-off, laid off staff, and tried to forget the whole sorry business. All told, Texas Instruments has sold 2.8 million TI-99s, quite a significant amount. Some products like the Milton Bradley MBX peripheral with speech recognition were quite revolutionary. Such a large install base drew a developer community. They began to unlock the full potential of the computer without risk of being sued, and better software began to be released. Parker Brothers offered good versions of the Frogger, Popeye and the Q*bert arcade games. Atarisoft produced Centipede, Defender, Dig Dug, Donkey Kong, Moon Patrol, Pac-Man, Ms. Pac-Man and Pole Position, showing just how powerful the TI-99 could have been as a video games console in 1979 had TI offered bitmap mode and encouraged the developer community. Software and peripherals were still on sale into the late 1980s, including our old friend Household Budget Management, now slashed to $9.95. Just how long they continued to be sold showed how much excess stock TI had produced, hoping for the payoff once the install base started buying add-ons. Even the original computer was still available, with suppliers suggesting you buy a second machine as a backup. Texas Instruments had taken their eye off the ball of producing semiconductors, pouring money into consumer products. They made digital watches, the Speak and Spell and computers, all markets that ultimately weren't profitable. By 1985, they were no longer the #1 chip maker. During this period, they'd let one long-time semiconductor employee go, Morris Chang. He'd go on to found TSMC in 1987, the Taiwanese company that would go on to dominate chip production with over 60% market share in 2024 and capable of producing the highest performance chips. TI went on to produce PC compatibles in the 80s and 90s, selling the business to Acer in 1997. The TI-99 graphics chip found its way into the MSX line of computers, as well as the ColecoVision video games console and the Coleco Adam computer. In the 2010s and beyond, coders showed what the system could achieve with ports of ZX Spectrum games like Manic Miner and Night Law. It helped the computer use the same 32 columns and 24 rows. There was even a port of Dragon's Lair by finding a way of essentially running video on an unmodified TI-99 4A. The TI-99's hardware architecture looked like it had been designed by a committee, which it probably had. They didn't choose the best chips, just the ones in the TI product catalogue. Other computer makers picked the best chip for the job, producing flexible, high-performance hardware that could be cost-reduced. Steve Wozniak would never have produced the TI-99 design. What's more, TI was secretive about how its computer worked and actively blocked developers who wanted to exploit its features. Companies like Apple published the architecture design encouraging bedroom coders to support their computer. You could argue Apple today does the exact opposite, but for parts of the system that customers want customized, things like applications and USB-C accessories, they provide extensive documentation and support. TI insisted on focusing on distributing programs on cartridge. This had the advantage of loading instantly, but they were very expensive and data files couldn't be stored. Floppy disks were the ideal solution for many, the right balance between price and convenience. Given all this, it's not a surprise that the limited range of software TI offered was poor quality, and when they picked a fight with Commodore's VIC-20, the TI-99 was always going to lose. The price war may have cost Commodore and certainly TI a lot of money, but it had one big benefit. 2.8 million machines got into a lot of homes of families that couldn't previously afford one, and that would give many their first start in programming. The Plato educational program may not have educated the masses, but selling almost free computers to a generation that became programmers is maybe the TI-99's lasting educational legacy. A big thank you again to Adrian's Digital Basement for letting me borrow the machines you've seen in this video. He does a lot of fascinating repair videos, and there's a TI-99 repair linked on the right. Thanks for watching, and I'll see you in the next video.